Hi, everyone. Today we're going to begin the introduction to the human body unit. We are going to be looking at my notes. Now, my notes are set up following the structure of the textbook that we used to use, which was written by Elaine Marie. And so these section numbers are going to be a little bit different than our digital textbook that we use for OpenStax. So please keep these two delineated when you're looking at PowerSchool. If it says the textbook section, that reflects the OpenStax book. And if we're discussing the sections of a video regarding my notes, that's this part here. So section 1.1, chapter 1, section 1, is just an overview of anatomy and physiology, and we're going to discuss the definitions and the relationship. We're going to then go into the levels of structural organization, and then skip body systems and finish up with homeostasis for this short video. So when you look at my notes, you're going to see that most of the information is already written for you. All we do is highlight or add a few notes to the side here. And this allows me to add analogies and further expand upon the notes for you guys. And you don't have to take as much time typing everything down or writing everything. So we're going to begin with the definition of anatomy and compare it and contrast it to the definition of physiology. So anatomy is it's a study of the structure and or shape of the body and its parts. Okay, so when we're looking at anatomy, we're looking at structure. We're looking at the shape of a blood vessel, maybe the shape of an aorta compared to a capillary. One's very big, one's very small. Or the relationship of the liver overlying the stomach and something called the greater omentum attaching and draping over the abdomen. And so we're looking at specifically structure. We never discuss how it's working. These here, this is always underneath a little bit of extra information, but you are not going to be obsessed on this. So what you're going to do is you're going to highlight anatomy. You're going to highlight the study of the structure and shape of the body and its parts and the relationships to each other. Moving down to physiology, once again, this is a vocabulary word. It's boldface, and this is a study how the body works or functions. Now, when I write functions, I abbreviate it F'(N) instead of writing this whole word out. And if you think about alliteration, the sound physiology and function, it has that same beginning F sound. So physiology is the function, how things work. So the tests that are being done are like looking at blood tests and how the heart reacts to exercise. Is the beat increasing or decreasing? So we're looking at cardiac output, etc. Whereas if we were looking at the anatomy, we'd be describing the blood vessels that come out of the heart or enter the heart, or looking at the four chambers, looking at the wall of the heart, how it's thick on the ventricle, on the left side versus the right side, etc. Now, one of the essays on your quiz is going to be describe the relationship between anatomy and physiology. So right there, the teacher has told you this is on the test. So you should be writing here, quiz essay. You should be being a big star and letting yourself know that you need to know this. This is definitely on the test. Well, and obviously, the definitions of anatomy and physiology will be as well. So there are two statements that you need to write down where I ask you, what is the relationship between anatomy and physiology? I'm not asking for the definition. I'm asking you to look at the relationship between the two. Now, with my essays, you can always write bulleted. You don't have to write out in complete sentences. You can use bullets and just get the facts down. The most important information is what I'm looking for, content, not the grammar. So first, the anatomical structure, the anatomy, determines the physiological function or the physiology. For instance, if something is shaped as a single long tube, it's more likely going to be meant to move something, be it a blood vessel, be it a trachea, a respiratory tube, be it a ureter, a fallopian tube, or in this case here, for my example here, the digestive system. So the shape, remember the body, the structure itself is going to determine what it's able to do. And then secondly, anatomy and physiology are very important They're separate, but they're very related because if you change slightly the anatomy, you put a blockage in a blood vessel, you decrease the inability of a neuron to release a neurotransmitter to talk to the next neuron. It will have a significant effect on the function or physiology. So even a small change in anatomy has a huge cascading effect on the physiology of that body or system. So those are the two statements that I'll expect to be written down for this short essay on your quiz. So that was section 1.1, just an overview, looking and comparing, contrasting anatomy and physiology. We're going to go into the next section, 1.2, the levels of the structural organization of all living things. Whenever you're covering any biological study, be it zoology, entomology, study of bugs, ornithology, study of birds, ichthyology, study of fish, you always begin looking at how life is organized and what are the needs and functions, et cetera, of living things. So there are 6 actual levels of living things. We start off, especially in chemistry, start learning about the chemical level and how atoms combine, they're covalently bonded or ionically bonded to form molecules. And as you start to move up through your education and your development of being able to understand things that are a little bit more abstract, you start to see that these molecules can actually organize themselves in unique ways to create cells. You have this dynamic cell membrane with that dual phospholipid membrane with embedded proteins. You look inside that cytosol and you start to see membrane-bound organelles. And now you start to see these organelles are starting to differentiate and take on jobs of the cell. So the cellular level is quite unique. And these are the smallest units of living things. When you start to clump some of these cells together that are similar, they start to form tissues, such as similar muscle cells forming a muscle tissue, or nervous tissue, or connective tissue, or even bone tissue. So a tissue are groups of similar cells that have a common function. Moving on, continuing with our structural organization, moving from small to large to the organism, you start to see that tissues are groups of similar cells that have a common function. And when you put these tissues together, they start to combine to form organs. An organ itself has 2 or more tissue types in it and performs a specific function for the whole entire body. The example here, a blood vessel may have epithelial tissue, smooth muscle tissue, and connective tissue. When you start to look at organ systems, the skeletal system, the muscular system, the nervous system, these are all the groups of major organs and supportive organs, they're called accessory organs, that cooperate to accomplish a common purpose. Excuse me. So each organ has their job to help the system function. And you can see my example here is the digestive system, including the major organs working together to move the food and absorb the nutrients. Excuse me. And then finally, the 6th level is the organismal level, where all the organs together form an organism. Excuse me. Sorry. And this, for anatomy, will be the study of the human being organism. So going back to the beginning, the easy trick for this is to remember the word cetos, C-T-O-S. Cetos, Cheetos, kind of sounds like Cheetos. And you start off, excuse me, with the C is actual double C, starting off with the chemical and the cellular level. T is tissue. Moving on to the organs, the organ systems, and then eventually the organism itself. All right, so we go from organs to systems, that's the S, and then finally the whole organism itself. So cetos is kind of a little trick to remember this hierarchy. And here's a nice picture using another analogy showing you how we go from just the chemicals to making molecules to making cells. This is a smooth muscle cell forming layers of tissue that eventually will form a blood vessel, which helps form the cardiovascular system, which is one of the 11 systems that helps create a human being. Now, as we move through the notes that follow the book, Marie's book, and it goes into an overview of all of the body systems. I'm going to hold this off till the very end of this unit. I'll be available next week to see you guys, and I want to get into something that's a little bit more challenged, that I want to see you in person and talk about the anatomy of the language of anatomy instead. So we're going to skip this till the end. And the last part of this quick unit video, which included 1.1 overview anatomy physiology, 1.2 the levels of structural organization, we're going to skip the body systems and we're going to go into homeostasis, 1.4. We're skipping all of this. You can read it for enrichment, but you will not be assessed on it. All right, moving on to page 10 of our notes, you can see the definition of homeostasis. Now, this is extremely important. Homeostasis is the body's ability to maintain a relatively, because everything fluctuates somewhat, stable internal conditions despite a change in the external environment. So let's say we go from an air-conditioned room that's 72 degrees, you walk outside of my classroom to 90-degree weather, and then you move into Landy Hall where it's considerably colder, maybe it's 68 degrees. Our body can adapt. Our skin goes through many changes to help us not lose a lot of heat or not gain a lot of heat, despite the changes in our external environment. That's called homeostasis. Our body wants to maintain an internal stable condition. Now, not only our body, this also reflects or is adapted to cellular homeostasis as well. Outside the cell, you'll see changes in concentrations of solutes, of salts, of electrolytes, and the body correspondingly changes to maintain a constant, stable environment inside that cell versus external of the cell as well. So homeostasis reflects not only the whole body organism, but also at the cellular level, trying to change and reflect and adapt to changes in the external environment. Now, when you have changes in homeostasis that the body cannot adapt to, that's when we start to see disease. We're going to skip homeostatic control of mechanisms. We're not going to look at positive and negative feedbacks. We're going to leave that for biology and apiebology. The letter B, though, the homeostatic imbalance, I do want you to know that when we are in imbalance, this condition can result in illness, disease. Now, for note-taking ability, instead of writing that whole word out, just write the letter D and the letter Z, the end of the alphabet, disease and or death. Now, aging is a natural process that starts after you've gone through puberty, you've become an emerging adult, and once you reach adulthood, we stop actually, quote unquote, growing, and now we go through the process of aging. The body becomes less efficient at maintaining homeostasis, and we start seeing increasing illnesses, disease, and the effects of aging. You can actually take a whole grad course on the effects of aging. I took that. It's actually quite interesting what happens to the body. Now, when you have abnormal body functioning, this homeostatic imbalance, it can lead to illness, one, disease, two, this is more chronic, this is short term, and or death. And I want you to be able to tell me if something happens to a human being where there's homeostatic imbalance, what are some of the effects? And it could result in these three things. Okay? Alrighty, so that is looking at the first section of the notes here that I had. And if you need to, you can revisit this video and re-highlight and add the couple of notes that I asked you to add to the side here. And I look forward to discussing more anatomy with y'all. Now I just have to figure out how to stop this. Hmm. Hmm.